Hey, in this video, we're going to be creating an object that can fire projectiles. So we'll make a player object that can turn left and right and fire projectiles straight forward. And so we'll see some parts of Unity and C# scripting where we will work with creating objects and giving them some sort of persistent motion. So over in Unity, I have a project set up that has just a player object. This player object is just a capsule, and I created a player controller script that I haven't done anything with yet. I'm going to attach that to my player object, and then I'm going to give this object some movement. So in Visual Studio, this is my player controller script, and I'd like it to be able to turn at least. Maybe I'll worry about moving it later, but I want to be able to rotate so that I can aim my projectiles. So I want to check out this input.getAxis function. The input object is from, this class is from the Unity engine, and getAxis will let me specify a particular name, like horizontal. And it will give me a floating point value telling me how much the player is pushing their buttons in that horizontal axis. So, for example, the default controls are set up to have the left joystick of your gamepad mapped to the horizontal axis. When you press left and right on your joystick, you'll get a negative number for this horizontal variable if you're pressing to the left. And if you're pressing to the right, you'll get a positive value. And the range is from -1 to +1. You get 0 when you're doing nothing. It's also, this horizontal axis is also mapped simultaneously to the arrow keys. So left and right arrow keys also give you that same -1 and +1. And there's an alternative too that's also mapped A and D, so that you can use WASD. And you can find these things in Unity if you go to the Edit menu, Project Settings, and then to the Input Manager. Expand the Axes category, and you've got a list of a bunch of different input mappings. So the first one is horizontal. That's the one that we're using, and so its name is horizontal with a capital H. And you can see that it is mapped using the left and right arrow keys. And then you can see the other mapping for horizontal, and this is the one for the joystick x-axis. We can also see that the horizontal, the first mapping, has alternative, negative, and positive buttons, A and D. And you can see all the other mappings we have. We have a vertical axis, so up and down, S and W. And you also have buttons for firing. And these are mapped as axes, but they really are treated like buttons. So fire 1 is one of our default mapped buttons, and that's on the left control or the left mouse click button. So we'll make use of that. And you can see that there are some other buttons that are also mapped. All right, so we can get this horizontal axis value, and we get a value from -1 to +1, and so we can do something with that. What I want to do is every frame, I want to use the input from the user to tell me how much to change the facing of this player object. So maybe I should keep track of that. I should have a variable and start it off at 0. And then when we press the left button, left direction, we're going to maybe decrease this facing degrees. And when we're pressing the right button, then we will increase this facing degrees. So this horiz value can be applied straight into that facing degrees, and this will happen roughly. We can expect if it's a 60 frames per second game, this will happen 60 times every second. And if we multiply by time.delta time, then this will change it so that we are changing by 1 of these degrees every second. If we want a different speed, then we should make a variable like that. So let me expose this to the editor with the serialized field attribute there, and give this a let's see, what's a good turn speed in degrees? Let's try like 90 degrees every second. So then we can multiply by this. Okay. So now we have this variable, facing degrees, that's going to be changing every second while we're holding the button. And we want this to affect the actual rotation of our object. So if we look at our rotation, let me select the rotation tool, and you can see this gizmo gives you a hint of how these rotations work. If I look at this green one, green is the axis that I want to rotate around, and that's the y-axis. So it's like a top with a line straight through it, and it's spinning about that axis. So that's the one I want to rotate about. Transform.rotation. And I'm going to change my rotation by setting it using the equals sign. So it's going to replace whatever rotation I had before. This is going to overwrite anything that maybe you had rigid body physics enabled and your object was spinning. This is going to change how that works. It's going to interfere with it. So be aware of that. But I'm going to set the rotation of this thing directly. And rotations are of type quaternion. And you don't need to know and understand everything that quaternions do or represent yet, but the quaternion class is capable of creating rotations in some other ways. So I'm going to be using the Euler function here, quaternion.Euler, because this lets me specify with one of these overloads x, y, and z rotations about those axes. So there are lots of details involved in how this actually works under the hood, and that you need to know which order they rotate about these axes, which axis they go first. And I think Unity does it about the z-axis first, then the x-axis, then the y-axis. But if I'm just rotating about one axis, I don't have to worry about that. So now we've got our rotation going, and I can test that out. Let me press one of my horizontal keys. And it's hard to tell that a cylinder or a capsule like this is spinning, but you can see in the inspector that this rotation value is changing. So it is definitely spinning. If I look in my scene view, let me grab this. Look in my scene view, it's a little more obvious because they have more debug drawing going on. So I can see how fast it's spinning. It's a little bit slow, so I'll crank that up a bit. Let's do 180 here. And so because I use the serialized field property, it's going to, or the attribute, it's also going to show up in the inspector for that component. Let me see. There it is. So down here in the corner, player control a script. We've got a turn speed and we can modify it there. In fact, I have to modify it there because changing the script doesn't change exposed variables once you change them from their default values. Okay, so we've got this guy that spins. And now I'd like to create a projectile. So let me create a sphere. And I don't really need to move it anywhere yet. But I do want to add a rigid body component, just so I can add some collision later. All right, and the rigid body component's important too because it it stores its own velocity property, and that velocity is applied by the physics engine. So it moves, it can move. So I'll call this my projectile. And then I'm going to make a prefab of this projectile. There we go. Then I can delete it from my scene, and it's stored as an asset now. So the player controller is going to let me press a button and create one of those objects. So I need to use this input class again. Check to see if input.getButton. So getButton will let me specify one of those button mappings, like fire1, and this will tell me if the button is held down. So you can do like a rapid fire. This will happen every frame if it's held down. And then getButton down will only happen once on the frame that it is pressed down. So if I just want to fire it every time I press it down, this is the function that I want to use. So let's see. We want to instantiate an object, and we're going to need a prefab reference in order to do that. So I'll put it up here. Let's serialize field a game object reference. All right, so our projectile prefab is going to be what we're instantiating. And there are a ton of overloads for this instantiate function. The one I use the most is this one, perhaps. I don't need to specify the parent. There's an original object I want to create from. I want to copy this prefab. Then I give it a position, which is a vector 3, and a rotation, which is a quaternion. So the position, I'm just going to say transform.position. So this is the player's position. And for the rotation, why don't we just take the player's rotation as well? And that should be fine. Instantiate returns a game object, so let me catch that in a variable so that I can use it. Now, I know that this projectile is going to have a rigid body component that that has a velocity property. So I'm going to make a reference rigid body, and I'll use the get component function to try to get access to the rigid body component. So if that game object has a rigid body component, this will access it. This will give me a reference to it. And if it doesn't, this will be null. So if RB is not null, then we got something and we can use it. RB.velocity. And then I can set this velocity. So I'll set the velocity, and I should probably parameterize the speed of our projectiles. So add some variable that's going to let us say how fast projectiles go. Let's do like 40 right now. So I'm expecting that to be 40 meters per second in these Unity units. So the velocity will be projectile speed times, and then I want to work in the direction that we're going. So the direction that we're facing is given to us by that rotation quaternion, but there's also a useful property on transform.forward, which is a vector pointing in the direction that this player object is facing. So our speed times transform.forward will carry that object in the forward direction. Then I think we should be pretty good with that. So as this rebuilds, it will show up my projectile prefab slot there in the player controller script. And I can go find my prefab, drop it in there. All right, let's see how this works. Okay. Looks alright. There's some weird things. If you notice, it's always coming out one side of my guy, but it's not necessarily going the direction I want. And this is weird, but it's expected because I'm not taking care to avoid self-collisions. The projectile is hitting the player object because it's spawning right inside the player object. So I'm going to disable collisions between the projectile and the player. One way to do this is to specify different layers for these objects. So my player, let's add a layer for the player. And let's add a layer for player projectile. And then we can disable collisions between any objects on those layers. Let me go back to my player and go set it to the player layer. And then in my projectile, I can set the projectile to the player projectile layer. Now, in my project settings, if I go to physics and scroll all the way down, there's a layer collision matrix where I can uncheck where player projectile and player overlap with each other or meet in this matrix. I might also want player projectiles not to collide with other player projectiles. Some games you might want that, but in mine I don't. And then we should be ready to check it out again. Alright, so that's much nicer. That's looking good. Alright, so there we go. We have created a script for the player controller that lets us turn and lets us fire projectiles, and we're using the rigid body component in order to make those projectiles move forward, move in some direction. I'll see you in the next video.